Tesla's self-driving revolution is here, but is it really the safer, cheaper, no-brainer future that we all want? While FSD uptake expands in the US, China, Australia and beyond, why is the UK trapped in a regulatory maze? Are legacy automakers the ones stalling progress? And when will your Tesla become fully autonomous? I'm going to need an expert for this one. And it's Dave Dewson. Thank you so much for joining me, expert. How are you?
I'm good, thank you. Yeah,
Great.
You're very welcome.
So we recently did a little on-stage presentation, didn't we? Talking about FSD on stage at Supercharged in the UK. And you blew my tiny mind with your knowledge of, of Tesla autonomy, FSD, regulation, LiDAR, radar, Gaydar, Darth Vader, all the DARs.
All the DARs.
So I wanted to sit you down today. I've got tons of questions to go through. We're going to try and keep it sort of simple enough to understand if you don't know too much about it, and also delve right into the weeds with all of those subjects. So
let's go.
But let's start with here's Elon Musk's explanation as to why vision only would become the obvious solution. He says LiDAR and radar reduce safety due to sensor contention. If LiDARs, radars disagree with cameras, which one wins? The sensor ambiguity causes increased, not decreased risk. We turned off the radars in Teslas to increase safety. Cameras for the win. And it's said many times in the past regarding the need for LiDAR and radar that these companies will find out eventually that they're heading towards a dead end. And if we humans can obviously drive with 2 camera eyeballs and a meatbag brain, and these Teslas are driving around with 8 high-definition cameras and evidently a more intelligent computer running it. Perhaps not now, but most certainly that's the way things are trending. You know, is Elon right on his assertion for LiDAR and radar, in your view?
Yes.
Great answer.
You don't need it. Trouble is, engineer takes over. There's always a little, it depends. And a lot of engineers will say, it depends. And it does depend, but fundamentally you don't need it. As you said, if you break it down to basics, a human doesn't need a LiDAR on top of his head.
Of course, we don't drive around with LiDARs.
We don't need radars pointing in multiple directions to see where we're going or know what we need to do.
That seems such an obvious point.
And you don't need to know precisely how far away you and I are for us to avoid bumping into each other. We don't need to know. We don't need to know to the millimetre how close we are.
And this is
fundamental. Good enough is what you're aiming for, but already with 8 cameras you can simultaneously take in that data, process it far quicker than a human can do it, and you're looking all around you simultaneously, and humans just can't do that. So that is already a big point.
Yeah, and as you mentioned with LiDAR during the discussion, you don't need to know millimetre perfect how far away you and I are from each other, do you?
No.
You just need to know roughly in the vicinity where that object is to make sure you don't hit it.
Yeah.
It seems quite
It's like, it's a bit of a guess, but everything we do is a bit of a guess.
Yes, the way we also drive our cars too. Yeah. So, okay, so why is Tesla's camera-only approach to self-driving vehicles better than LiDAR or radar-based systems?
You have to define better, because better is it important that I know precisely how far away I'm from the next thing? All of these technologies have they have downsides as well as upsides. LiDAR produces this 3D point map, which is a load of dots. Imagine a load of dots of everything, the distance to every single thing that's all around it, and it scans. So it has to. The early ones had a spinny thing. I mean, we all think of the spinny thing. You still see but it has a limited aperture, so it's looking at so many degrees out from here. So what you find is you put one on the roof of your car, you find you've got a blind spot, so you need another one, and then you have to put another one on because you can't see on that side, and then you need another one because you can't see on that. So before you know it, you've got 4, 5, 6, 8 of the things, and then you've got as many cameras on top of that as well. Yeah. So what you get is a load of data that does technically make it better.
Yes.
But you've then got to deal with all that data.
Because it doesn't give you a solution to scalable autonomy, does it? Because what's the point in having cars that are tremendously expensive, covered in sensors, if you can't build them for customers?
No. So for a one-off prototype or a few hundred, it's fine. It's absolutely brilliant.
So that's why Tesla, I suppose, are getting the pushback, because they seem to be, from people who are new to the situation, like they are just going for the cheapest possible option to save money, and we're just going to we're going to turn off our radars. We just have cameras because that's the cheap thing to do.
Yes.
But it's the only scalable thing to do, isn't it?
It is at the moment. LiDAR's getting cheaper. Radars are already cheap. You can throw LiDARs all over a vehicle and they're a few £100 each, depending on which ones they are. You get long range ones and short range ones. And a higher spec vehicle that doesn't use vision, it is using vision. Most vehicles are using vision for lane guidance and things like that because that's the only way to do it. They tend to go onto radar for safety stuff and even pedestrian stuff. So these blind spot things that you see, the blind spot radars that you get a little thing pop up in the wing mirror, they've got 5 short range radars around the vehicle to do that, to implement that thing. The point is, if you can get vision to work, which is harder, you don't need all that stuff. You can just get rid of it all. Just delete, just get rid. You don't need it.
Yeah.
So you get rid of it all. And yeah, I've got some facts about how Tesla's lane depart system works that are fantastic. Makes it much better. And I don't know whether you want to get into that.
Can you just mention your lorry example then? Just to clarify, this is a test for radar systems.
Emergency braking systems.
Right.
So there's 2 parts to it. There's a high-speed part, a high-speed moving part, where the target vehicle is actually moving at 10 kilometers an hour. Your test vehicle is moving at 80 kilometers an hour. And as the 2 close together, they must completely stop. So your vehicle must completely stop. This is a radar deficiency. Radars don't work very well when the target is actually stationary. So there's another test where you only have to remove 25% of the main vehicle speed. So it still plows into the back of the...
That's not a win, is it, for anyone in that car or vehicle? So,
and if you dial up the radar so it's sensitive enough to pick up stationary objects, because it's like a static, noisy image that radar works by Doppler, it's frequency shift, and it needs to have movement in the scene to actually pick something out. So it struggles to see a stationary vehicle. It just won't see it until the very last minute, and then it's too late because physics.
It needs vision anyway. Then it needs cameras.
The newer systems have an amalgam of sensors. They have a fusion of sensors, and the high speed stuff is done by the radar because it's better at that. The low speed stuff is done by the vision because the vision is better at low speed.
So when it does have a conflicting moment between LiDAR, radar, and cameras, who gets to win? Who's
Tends
the boss?
to be the speed.
Okay.
It trusts the camera more at low speeds than it does the radar.
It's terribly complicated.
That's how they're doing it. That's how the others are doing it.
Okay. Yeah.
It is complicated, and you've got a mass of equipment adding to the vehicle, adding weight and cost to the vehicle as well.
Let me have a brief reminder of how Tesla's FSD works, and correct me if I'm wrong on this. So the question I put to Grok actually to ask this is, how does Tesla's FSD use video clips to train its AI? Because that's what it's all based on nowadays, isn't it? Tesla's machine learning for full self-driving is trained on millions of video clips collected from its fleet of vehicles, capturing diverse real-world driving scenarios. These clips are processed by neural networks to teach the system to recognise patterns like road signs, pedestrians or lane markings, and predict safe driving actions. The AI refines its decision making by learning from vast data, improving over time to handle complex situations like city navigation or traffic responses, all without relying on LiDAR or radar. So this to me, it does make sense because it's learning from more situations than we'd ever experience in our own lives, isn't it? It's got if a UFO landed in front of a car, a Tesla in America, and then the next minute it's just sent out to all the other cars in the world what to do in this situation. That seems to me a more progressive, path to be on. It's a better system to teach all cars, all vehicles how to maneuver in these situations.
It is,
Yeah. How does Tesla prove that its full self-driving is 10 times safer than human drivers? And will UK regulators accept this?
Data. Lots and lots and lots.
Going back to those millions of videos.
So if you take traditional auto will buy a system to do their emergency braking or their lane keep. They'll buy a system from somebody else. When they buy that system, it comes with a body of information, which is all of the testing and the rigorous stuff that they've put this piece of technology through to get to the point where it is. So all of its compliance, all of its electromagnetic compatibility and all that kind of stuff. And that giant folder full of situation data that means that they've tested this and they've tried this and they've done this, and they back it all up with lots and lots and lots of data. So when you're a manufacturer, the engineering teams are going, well, we can buy this thing in off the shelf and it's got all this stuff with it, and we just submit that with our type approval. And that's what happens because that data is there. It's already been accumulated by a company that is recognised to actually produce those kinds of things. They've usually got, when it's a new system, they struggle because they're trying to collect enough data to prove that the thing works properly, and it works when it should and it doesn't when it shouldn't. So Tesla need to present that data. When you take that third-party hardware and put it on your vehicle, you also have to do additional mileage to prove this thing, to prove that it's installed on your vehicle correctly and it still works correctly as it was designed to work. So you have to go and do 20, 30,000 kilometres with that vehicle before you're allowed to use that system. Usually by the manufacturer of that system says, you must go and do this data. We're going to rig your vehicle with a load of sensors and a load of cameras and things to monitor while you go and drive it around. And every time it gets a safety situation occur, we're going to download that data and we're going to look at it, and that's how it works in the industry.
Is there? I might be going off on a tangent a bit here, but because there's no lines of code to look at in Tesla, and it's all neural nets. What are they looking at exactly?
They don't usually go through lines of code, but obviously they can if they need to. What they tend to do is they want a solid version. So when you submit for approval, you give a version number, and that's the version that you've done. And this is where Tesla will struggle, is that they keep changing their version numbers. And effectively, if you're doing a mileage accumulation test, you need to put some software on at the start, and you need to run all of that test on the same software. You can't change it in the middle.
And they're constantly changing it.
And they're constantly changing it. So as soon as you're accumulating data, and they go, oh, we need to make a change, 0.
Right, start
we
again.
need to make a change, 0.
Okay.
So as soon as you reset to 0, now you're allowed to do a certain percentage of changes without having to resubmit. So if you've already got an approval vehicle, and I'm thinking about my lovely Hardware 3 Model 3 that's parked outside, Tesla will have to go through type approval for that, because this change to go to FSD, proper supervised or even unsupervised FSD, is huge from type approval point of view. The behaviour of the vehicle changes entirely. The software is completely different because there's no lines of code, it's all neural nets. Will Tesla want to go and do all that work for Hardware 3 and Hardware 4?
We'll get to that question in a minute with Hardware 3, because I can imagine there's lots of people wondering,
me included,
you included, like whether it's ever going to come. Tesla's full self-driving neural network files, which enable the advanced end-to-end neural network capabilities for autonomous driving, are not yet in European Teslas, but they are just an over-the-air update away, aren't they? Is that right?
They are.
Are they? They are in the cars, or?
I think they're in the cars.
Yeah, I thought you did.
So one of our good friends down in Australia have just got FSD supervised in a limited form. It's not out to public yet. It's with media.
Shout out to Ryan's
kindly
Model
posted.
Y, is it?
Was it right? I don't know if it was Ryan. It was Tech AU. I don't.
Oh, okay. Yeah. Oh, there's a few of them. They're all just like rolling around now in their FSD.
I know. Where they're look how great we are.
Cracking time.
They posted for the nerds, that's me, the file sizes of the AP banks in service from service mode.
So what secrets did that give you then?
They're exactly the same as ours. They're exactly the same as a Hardware 4. I've checked Model 3 and Model Y. They're exactly the same.
What does that mean in layman's terms?
So it looks like the Autopilot core files are exactly the same files as the ones that we're running in Europe right now. The front end file that runs the screen, the UI on the screen is different. So that's a different, and that's where the part number is. So we're running 2025.32 or something at the minute. That's one of the latest versions. They're on a slightly older than that. They're on I forget which one it is, but it's a slightly older file, and I believe it's literally like flip a bit and it's alive.
So it's just ready and waiting.
Yeah,
the beast is there and waiting.
Potentially it needs a different front end because it's got all the new visualization stuff in it.
But whether it's in there or not at the moment, it is just like an over-the-air update.
And that makes sense because Tesla can still accumulate data from that AP core.
So what excites you about it being on there at the moment then?
Well, it means that it means that our version in Europe is being completely nerfed by regulation. If it's the same core,
right,
and our friends in Australia are driving around with that same code, we get some version and then it has a load of restriction piled on top of it to make it compliant with the UNECE regulations.
Right. So I'm trying to think of how to put this in words.
hugely frustrating.
So, right, I'm trying to figure out still why it's frustrating.
Yeah.
I'm understanding the words you are saying.
So we're not even waiting for the software to be delivered. It's there already.
It's there. So everything's
is,
here. It's just
there.
regulation getting in the way.
It's literally there's a bit somewhere in a bit of code that is not flipped that says this is allowed to use.
Right.
Turn off all the restrictions and here you go.
Yeah, I mean, obviously we're getting very into the depths of FSD, but if you just zoom out a bit, this is coming.
Yeah.
In 5 years' time, let's say, I'd imagine this conversation is going to be totally irrelevant. It's just, we're in the weeds of how long it's going to take the UK, but we're seeing around the world that it's happening right now. So this is not alien technology, is it?
No, it's there. And the main thing is, you stand in one of those delivery centres for Tesla, and the room's full of hardware for cars, and they're all there. They're ready. They just literally an update, if it's an update, or even a bit switch to make it happen. A bit like when you ask for acceleration boost, nothing downloads to your car, something flips a bit in software and it comes over the air.
Right.
You don't have to put an update on. It literally just happens, and it happens within minutes.
Okay.
Tesla sends something, and that stuff gets enabled. Same with FSD, same with EAP.
So like when you subscribe to
Premium connectivity.
Let me play devil's advocate for just a moment here, because Tesla claim that Autopilot is 10 times safer than a human driver. But if you're driving and you are paying attention, like a good person at the moment, with anyone who's driving autonomously in Tesla with just standard Autopilot, if you do come up to have to intervene, if there's an accident about to take place, you would take over.
Yes.
So then it's not on Autopilot anymore. So those miles are not being counted as Autopilot. So technically there's a bit of a...
Technically you've taken over.
You've taken over. Yeah. Yes. So that 10 times safer as a human. And then I've got another problem. Because in the interest of balance, I've got to throw out what I'm really thinking that's in my mind for the interest of just trying to get to the answers. I want to be proved wrong here. But if Tesla are only collecting miles taken from highways and motorways, statistically the safest places to drive on, that is also weighing in Tesla's favour against companies like Waymo that are driving on city streets more often.
Yes.
So, what are your thoughts on Tesla's, on what's the word, on Tesla's gathering of data to show that they are 10 times safer?
You have to decide somewhere to draw a line and say this is what we do and this is how we're doing it. But I do it in my car. I'm rolling down the road. I've got my EU FSD, and if I see something happening before my computer spots it, then I can take over. Yeah. And that technically that counts as I've intervened and I'm driving it manually.
Yeah. And those Autopilot miles will go down as a big tick for
big
Tesla's
tick.
10
we drove
times.
because I've come here today. I've driven about 90 miles to come here today. I drove most of it with my FSD EU version of the software, and the car did pretty much all the work. Lane changing, the whole lot. And I had to do my little bit to confirm that I'm there and I'm doing stuff. And I found it very relaxing and very easygoing. But there were instances where I took over, where it wasn't going to do what I expected. And a lot of it was my learning of 100,000 miles with it, because that's how many miles I've done with it now.
Yeah.
I know when it's going to go wrong. And because it hasn't changed much in this region, I know when it's going to go wrong. I can see the situations coming a mile away.
Yeah.
You'll get some dodgy lane markings or something. You'll see somebody do something, and it. But then there are instances where I don't see stuff, and it avoids stuff and takes over. And a lot of the time it gets branded as phantom braking, but it's usually you haven't noticed something.
Well, I'm thinking of which direction to go in, because one of the very early things that got me so interested about telling the world about Tesla was the fact that we got onto the motorway and then I hadn't seen a car that was about to swipe into the back end of us at 70 mile an hour, and it would have spun us round in a pit manoeuvre, and my two little kids were in the back, baby at the time and little Frankie, and at that moment I just kind of I get it, because it moved us it just moved us across.
Shunted you out the way a bit.
I didn't know the car was coming.
Yeah.
I'm like, oh my God, this technology. This might have just saved our entire family.
It is.
And what I'd love to see is some great big counter that Tesla could store the information from people's
Yeah.
almost crashes that it's
Tesla saved
avoided.
my bacon.
Yeah, because you can even
That's what it
imagine
is.
how much footage they've got of near misses where Teslas have taken over.
Yeah.
I mean, show people that. That would be a great
It's very,
thing to do.
and we're very limited in what our EU cars can do in terms of regulation. The responses it can do is very, very restrictive.
So that's frustrating as well.
It is
We'll
very
get to that
frustrating
in a minute as well.
because those laws are like 20 years old,
Yeah,
and we're still fighting those things. They put those things in place, and we can't do it.
yeah.
It's not allowed to do it. All it's allowed to do is press the brake pedal. Really.
Yeah.
It can move a little bit.
Well,
It's not really supposed to steer input.
let's mention that now then. So
Yeah.
this is advanced autopilot. You were talking about the lane maneuver
Yes.
issue,
Yeah.
which I don't have advanced autopilot on
Okay,
mine, so I
yeah.
don't know what this is. But when you and Josh were talking about it,
okay, yes.
and you were saying
Yeah.
it,
The
you know, it's-
timings.
Yeah, the timing.
Yeah.
It's you press your indicator, it
Yeah.
starts moving it into the next lane,
Yeah.
and if it times, if
Yeah.
it has made the lane change within a few seconds, regulation says you've got to go back to
You've
the
got to go
first
back
lane.
to where you
That's
started. Yeah,
insane,
yeah.
and that's regulation.
So you're driving down the road, you decide you want to do a lane change, or if you're in Navigate on Autopilot, the car says I want to change lanes and it recommends a lane change, and you have to confirm that. That's your first one. So the car
the
says,
regulations,
the
like,
car knows
confirm
it wants to change lane. It's looked at the traffic around it and it's going, I need to change lane because I'm catching up with this stuff in front.
Yeah.
So the car can't do that. It's called a SIM. System initiated maneuver, and we're not allowed to do that in this region. So that's regulation. The first regulation you've come into, you can't have a system initiated maneuver. We did have some, but I'll tell you about that in a bit. They were great. They sneaked through by accident.
Oh.
So you indicate, because the car says, I'd like to change lane, please. So you indicate. The car then has to wait 1.5 seconds before it can do anything, even though it's been watching down the road for the last, 30 seconds, and it knows that there's a gap, and it's recommended a lane change, because if it can't change lanes, it won't recommend it. So it has to wait 1.5 seconds. If it's clear and there's nothing too close, and the too close is quite a big distance, it's maybe 3, 4, 5 car lengths between the where you are, the back of your car is, and where the thing is that's overtaking you.
Yeah.
If there's something there, it's not allowed to move into the lane. It can't do an acceleration or anything like that. It has to complete the maneuver after the 1.5 seconds. Within 5 seconds, it must be in the next lane, or it has to go back to the start. And when it does it, it times out. So you can count, and when you're used to driving it, you count in your head.
That seems,
subconsciously, you count.
Counterintuitively, that seems more dangerous to have
It
in
is
place.
dangerous. It is.
The regulation is making things more dangerous.
Because if your vehicle's halfway through a maneuver on its own, if somebody on the other side decides, oh, I'm going to go out there as well, and they start coming behind you, your car will swerve back into the lane. Because humans can't see 360 all the time. They will look and they'll go, oh yeah, he's going, and then they start to manoeuvre, and your car comes back all of a sudden.
Is there any?
Now, would it hit? I don't know.
Is there any pushback against that then? Because that to me seems crazy.
I'm not aware of any.
Or is it just like, here's the regulation, that's it, end of story?
That regulation was written a long time ago, so it's not been updated. We haven't had many updated regs in this part of it for some time.
Right.
We had some stuff to cover level 3 autonomy, like the Mercedes thing.
Oh yeah.
Which is a page of caveat of things you can't do, things it won't do.
Yeah.
Oh, the sun's in the way, I can't do that. It's raining, I can't do it.
Well, we'll get to the competition later. There's not much to talk about, really. Yeah. Okay, well, while we're on hardware 3 then, let's do it. So can Tesla's hardware 3 or hardware 4, using parallel core processing to handle tasks like camera analysis and route planning simultaneously, support FSD's demands? That's a hell of a question, isn't it, that one? But
that's a big one.
I'm trying to keep up with my own question. Come on. Or will UK regulators require more physical backup systems? So let's talk about hardware 3 and hardware 4 redundancy systems.
Oh, yeah.
And I'm going to really activate my brain to keep up.
So your car and mine, as built.
Mine's hardware 4 now.
Yours is hardware. I've got hardware 4. The hardware. So if we go back in time.
Okay.
Back in time, hardware 2018, hardware 2.5, back in the States, because we didn't get those cars, did we? We had to wait for ours, Will.
Yeah.
They ended up being updated to hardware 3, if you remember, because Autopilot progressed and hardware 2.5 cars weren't capable of running that stuff. Mm-hmm. So if you bought an FSD back then, you got something, I don't know what it was or how good it was, and then rapidly hardware 3 needed to be added to those vehicles. So they got a free update to hardware 3 because the software wasn't ready. They bought FSD, They had to get a hardware 3 upgrade. So that happened, and that was nice and easy because...
There wasn't many Teslas.
well, there wasn't many Teslas, and it was the same size physically.
Okay.
The compute module was the same size. It all had all the same plugs on it, and there were no camera changes or anything like that. So quite a lot of the hardware was ready, but the compute module wasn't good enough. That update happened. That's great. What the vehicle has in terms of redundancy, and all those vehicles back in 2018, and this is where the foresight of Tesla comes in, and I'm still blown away by how far in advance they think about these things. They had cabin cameras that were never used for years and years. They all had front radars, and they had wiring to a front radar because they were using front radar for emergency braking.
Yeah.
And maybe for adaptive cruise control as well. I'm not sure, don't know. Difficult to know whether it's used, because most radars come with an adaptive cruise control function built into them. The radar does the adaptive cruise, the rest of the vehicle doesn't, other than a few things to switch it on and off. It doesn't need to do anything else. It just needs to respond to commands from the radar. And that's what happens when it does emergency braking. The radar says, I need to stop, and it takes over the whole vehicle's brake system. And once it goes into an emergency procedure, it's controlling the vehicle's brake system directly. The rest of the vehicle is almost completely just not involved in the process at all.
Oh, okay.
So the radar takes over, and it does something called an external brake request, and it says, I'm going to brake. You can get out of it. There's ways of escaping from it. Their hardware needs to be, you have redundancies in these things, so most of them have multiple wires. Now, Teslas were obviously thinking about full self-driving way back in 2018, because all their vehicles have redundant wiring to the steering, redundant communication. It's an electric power steering. How am I going to do this without getting too complicated?
That's right, I'm keeping up.
Electric power steering system.
Yeah.
Have you ever seen it?
No.
It's like a steery thing with a big motor on it on the top of it.
Okay.
And you used to have hydraulic power steering, didn't you? In your old cars, they had a pump on the front of an engine going chug chug.
I'll take your word for it.
So then in newer cars, electric power steering came along, and they got rid of all that stuff. So they simplified the design and made it much easier. And it's got this big motor, electric motor on the top of it. And a lot of these are made by Bosch. They're actually not made by Tesla, they're made by Bosch.
Oh.
So it's a Bosch part. It's all been type approved, and it's all safe, and everything's great about it. So what it has is a facility to take two separate power feeds to it from different sides of the vehicle. So if something happens on this side of the vehicle and it gets damaged, the steering still works because it's got a power feed on this side. The same with the communication. So it's actually got a primary communication and a secondary communication. So all of this stuff that tells the power steering what to do comes over a CAN bus communication, controller area network.
Yeah.
And they put separate bits of wire for the power and separate bits of wire for the communication. If something happens and something gets damaged, or if a rat chews through half of it, it still works.
Yeah.
It still functions. It's redundant. Unlike you, if your arms fall off, you can't drive a car anymore.
Big bummer.
You would, wouldn't it?
Unless I had FSD.
So you're not redundant. You don't have a redundant system.
Yeah, okay.
And then you have multiple redundant
But hang
systems.
on, if one arm fell off, I've got a redundant arm here.
Ah, well, you might be able to still drive with one arm.
Yeah, exactly.
You'd have a knob on the thing.
We have redundant eyeballs.
Yeah, we do. Yeah, there is some
quite a bit
redundancy.
built in, I
Yeah.
suppose. There's some organs
Yeah.
we can live
If only
without.
you'd concentrate, you'd drive a car properly.
Okay, so basically, Teslas are built with a ton of redundancy.
They are.
In terms of their
Already.
hardware and their software.
For years and years.
For years and years.
Years and years.
And even the motors, I suppose, having twin motors in pretty much most of the cars, gives you a redundant motor.
It does.
But mine's only a rear-wheel drive, so it's only got one.
Well, yeah.
But
they
why
don't
not?
break, do they?
Exactly. Why not just
Yeah.
make things that don't break in the first place?
Yes.
Like my Bosch drill, by the way, I've had for like 40 years. It's in
Yes,
my garage.
it still works.
Actually, it broke last week.
Yeah.
But 40 years, it's not bad.
It is, yeah. I've
Yeah.
seen a lot of, there's a lot of industrial equipment that lasts that long. It's
Yeah.
really, really good.
Yeah.
It's simple, it works, it's
Yeah.
functional.
So
The likelihood of failure is very small.
Right. I'm going
Very,
to
very
throw in
small.
a quick question
Go
about Bosch. Why, with all of Tesla's vertical integration, have they not built that component themselves then? Because I do believe
know.
they build most components themselves. Or I guess this thing is so off the shelf and it works well and is affordable.
Well,
Why
and
not?
this all comes back to this type approval thing. If you've got a component that you can buy that does everything you want it to do, and there's millions of other vehicles running around with it already, because there are a lot of vehicles have these systems in already, and it's mostly because of cost. It's actually cheaper than a hydraulic system. It's less complex, it's cheaper, and you can do clever things with it, like change the steering weight for different speeds and stuff like that. So you can do lots of clever stuff with it. It comes with a giant body of evidence that you could submit for your type approval that says my system works really well, and it's on this one, and this one, this one, this one as well.
You have to start from scratch.
So you'd have to start again.
Okay, it makes sense.
Yeah, and that's kind of where FSD is. because nobody else is doing an FSD solution that, with this vision system and a compute stuff. You haven't got, nobody else is doing that.
Right.
So some of the Chinese are doing it. So there are these redundancies. There's multiple cores in the AP computer and always have been. It's a design thing. If one fails, the vision goes into the top, is split and goes through each core, which runs the same code. And at the end, the two files are compared and they go, yep, that one matches, there's a command. I can steer, I can drive, I can do things.
So the car won't function unless its two lines of data both corroborate with each other.
Exactly, yeah.
Mind-blowing stuff.
In 2018.
Yeah, okay, 2018.
Yeah.
So, okay, let's move on to hardware 3 then.
Yeah.
Okay, so we're not even there, are we? So,
yeah, so
how have things changed then to get from hardware 3 to hardware 4?
So the compute level has gone up. The compute level, the level of compute, I forget what we were, it was 114 tops or something.
Right, trillion operations
Trillion
per second?
operations per second.
Right.
Yes.
Okay.
And that's very focused inference engine stuff. It's like a GPU, a general graphics card. It can do inference really well. It can do this compute stuff that's needed for neural networks. But it's also got a lot of stuff that you don't want. It's got all this luggage that is drawing power, and you're in your battery electric car. The last thing you want is a giant, a box full of GPUs drawing energy from your battery, because that's you can't go further. You've got to carry it all around. Yeah. And you've got to so it's got weight. And you need to run it with power. You need lots of energy to run it. So you don't want that. You want a dedicated chip to do this function and do it really, really efficiently. So hardware 4 jumped up to something like well over 200 tops. It's really, so the performance of the thing means it can do more compute much faster, and actually uses less energy. I think. Does it use this? Wow. It might be a bit more. Okay. Yeah, so a tiny bit more.
How much of it is redundant itself then? Because I'm guessing they've sort of over-spec'd it in order to carry out future operations, because the inference thing, in the future where you'll be able to have your car do other computer tasks while it's static, and probably in the future while it's running FSD as well, because you just have loads of.
It's another stream of something, isn't it? Another revenue stream.
That's another flipping big dark rabbit hole.
Because it's,
I don't really
the
understand.
idea is it's not sat outside for 90% of the time, is it? It's off doing stuff for you.
Yeah. Okay.
It's not parked all the while, but if it's idle, it could be doing other stuff.
Yeah, I imagine that will happen in the future. Okay, so we've got to the level where we're at with hardware 4. Yes. It seems to be working really well for the people that are using it. It's certainly, there is a path to making it beyond human capable with hardware 4. Yeah. So the big question is reverse engineering it to be used on hardware 3 cars, which seems probable based on the re-engineering aspect of it. Okay,
so if you want to transplant, so we've heard from Elon, he says, we're going to look after people. He said that. We're going to look after you. And I think he put his head in his hands and realised how big of a task it was as he thought more and more about it. But the computer's bigger physically. The connectors are in different places. It's not really designed to be take one, bolt one and plug another one in. I think the coolant lines are different on the back. It's a water-cooled GPU a water-cooled compute system in your car from 2018. Okay. It's just so advanced.
But with all that foresight from before, what we're talking about, why didn't they have the foresight to go, hang on a minute?
Well, they've reinvented the wheel several times over, haven't they? They tried doing heuristic code, is what it's called, lines of code to drive, and that's what we've pretty much got. That's what ours feels like, with all the stuff on top of it. But it feels like we've still got a lot of lines of code that are interfering with how our systems work. I don't
understand why they wouldn't have just had a universal computer size or something that you could just transplant from hardware 3 to hardware 4.
I think because of the reinvention, because of the approach they've had, because they changed from they were doing lots of heuristic code, and they reached that they call it a local maximum. Where you're putting effort, and you're just getting no return at all. You just can't get any. Yeah, you're trying and you can't get any.
Hence they have to keep starting
and
again.
they just literally ripped it all up and started again. I mean, it's.
So to get back to that point then, when Elon suggested that, okay, if it doesn't work on hardware 3 cars, we will change it to hardware 4. But you're talking millions and millions of cars now. There's a lot more than there was back in 2012 or 2013.
And we're also dealing with regulation that hasn't really been finished written yet. There is Grok stumbled on something for me the other day. The steering system, although it's got multiple comms, it's got multiple power, and it's quite a redundant device, it doesn't have two motors. It only has one motor. And it looks like UNECE might be saying that fully unsupervised driving will need a double redundant steering system.
Yeah.
And I quizzed Grok and I sent him part numbers. I call him Grok, because it's like chatting to somebody else. Like you're a very intelligent mate, isn't it?
Yeah, absolutely.
Everybody's got a very intelligent mate. I sent part numbers and I said, because I was trying to get a comparison between where we are with hardware 3 cars and where we are with hardware 4 cars. And I sent the part number, I looked at the Tesla parts catalogue, the online one that's free and everybody can get to. And I pulled the part number from my steering rack and I looked at it, compared it to a hardware 4 steering rack, and it's the same number. It's changed version a little bit at the end, but it's the same part. And then I said, but in order to meet this requirement, you need a dual motor steering system. And Grok came back and said, the test cars that Tesla are using in the UK is using this part number. And it said another part number, which is a dual redundant rack.
So you think that's what they were driving around in London?
Yeah, I think that test car might have a dual steering system rack on it, a dual motor rack on it.
What does that mean though for the rest
of us? So that means that hardware 4 cars in EU regions might, depending on what the regulations end up being, and they might go, so what they'll probably do is pull a body of evidence and says, these racks don't fail, they don't go wrong.
Yeah.
It's less than 1% of failure rate. And get some kind of dispensation for it and say, look, look at all the data, look at all these. There's millions of, because it's not just Tesla. There's loads of people are using these things.
Yeah,
they don't go wrong.
That would have to be the solution, surely. The regulation has to change to accommodate some level of.
And it could also be an AI thing. Grok might have got it wrong, but he did whisk this part number out of thin air and he said, I think these are maybe it's been retrofitted with this. And I'm like, really?
Really? I've got a feeling they're not.
So you need. There's a significant difference between. So the compute's much bigger on AI4. You've got your funny little red eye cameras. Yeah. And that's pure AI on its own, isn't it? It's like a Cylon looking at you.
It's always been bad news. Just putting red flipping light bulbs.
So you might need to change but changing cameras and changing compute, even though the wires are all in the wrong place, and apparently there's not enough power for the new compute module either. You need to run extra wires to give you more current to run.
Someone did tell me, I can't remember who it was, but all the wires would need replacing too, because they won't be adequate enough for hardware 4. But I might be wrong about that.
I think most of it will be okay. If hardware 4 has a higher power requirement, the cables might not be big enough.
So they have to rewire the car.
You might have a patch harness to make it bigger.
Right.
And this is maybe why Elon's groaning about it.
Well, I bet he is, yeah.
Because you just you can't go, and how many of us are there that need upgrades? So is there, how many people have, like you've just changed to hardware 4. So you've got all that stuff. You've got the upgraded cameras. You've got the bigger computer. You're there with all that performance. You've got your extra camera in the front bumper. Is that we're told? I think Lars said that's not being used.
Well, I use it.
Yeah. Oh, yeah. You're plugging it into your meat brain.
Yeah. I noticed that.
Your meat computer.
It's great. That's lovely. So the worst case scenario for hardware 3 users, I'm assuming, will be this. They will figure out how to do supervised FSD.
Yes.
And you will be able to use it far in advance than anything that we're doing now in the UK.
Yeah.
So that's still not bad news, is it?
No,
it's still you'll have a semi-autonomous car for a long time. Yeah, exactly. Because most of the time, and then we're not going to get into this conversation as well, but the whole enjoyment of driving thing versus you want it to be taken over. There's a whole can of worms there, which I have discussed ad nauseum.
I love driving. I love driving.
Me too.
But driving up the motorway, 80 miles. Yeah, and 80 miles up a motorway in the UK is not a fun experience.
No, and in traffic and stuff, it's not fun. So my point is that hardware 3 users will be able to use. And benefit from Tesla's FSD system at some point to some level.
I believe they will
be fully autonomous.
Yeah, I believe they will distill. So there's a procedure that you can do in generating when they compute neural networks with their supercomputer. They can set various resolution settings. That means that you can take a really big model and you can actually reduce its resolution a bit so that you can sort of cut it down. So it's a cut down version of it that will fit in the compute platform and deliver the speed you need for hardware 3, but it's not quite the same resolution. It's not as finessed as hardware 4 would be.
Sort of thing.
Yeah,
but in compute,
it's like a better frame rate in a game.
Yeah,
that might be the best analogy.
But still,
it still works, and you can still play, and it still works. But so
there's still a possibility.
Yes. Yeah.
Even with hardware 3. Okay.
But I don't think unsupervised will happen.
No, but supervised, which will still be a huge benefit to a lot of people with Teslas. What technical and legal hurdles must Tesla overcome for FSD supervised and unsupervised in the UK? And when could they realistically launch?
Oh my goodness.
Sorry to ask, but it's the question everyone wants to know. What's the flipping hold up is the question.
So I believe there's an end of September date for system initiated manoeuvres.
Okay.
But that's not final yet. So we may or may not be able to do auto lane changes with our autopilot systems as they are now on motorways at the end of this month, because it's 1st of September.
Right.
Yeah. So we may be able to do that. The rest of it is trawling through committee and endless meetings all over the world. We won't get into how eco that is.
Well, yeah, okay. I almost want to ask the next question now then. So before I carry on, UNECE is the United Nations Economic Commission for Europe. Okay, so here's a question for you. How do UNECE's ties to legacy automakers like BMW and Audi slow down Tesla's FSD approval in the UK? So something you absolutely blew my mind with at Superchargers when you were telling me you were stumbling across email addresses from legacy car makers in the very meetings that are going on with UNECE. Are Tesla there?
There are all sorts of things that go on, and so if anybody who's a member party of UNECE can object to anything that's going through for approval. So if any one person says we don't like that idea,
so if let's say I'm BMW, but I don't like that.
Yeah, you can. It can get blocked because of that.
And do you think it's in the interest of Legacy Auto to get involved with this and try and slow down progress for FSD, knowing that they don't have any solution for it?
I mean, has anybody else got custom silicon solution to drive a car with? Their own silicon that they've fine-tuned and honed to be a precise thing for doing that specific purpose? Because I'm not aware of anybody. You can get third-party stuff that is, you bolt in and you use this thing. But we come back to things like if you've got lots of sensors, because we talked about having lots of sensors. If you've got lots of sensors, you then need lots of compute to deal with all that stuff. And you're going to use more. If you've got 5 times the sensors, you're going to use 5 times the power to run those sensors and to process all the data that comes off those sensors in order for them to be any use at all. So I think regulation is just hard. It's just not. The Australians have got away with it because they're not really a full member of UNECE as far as from my research.
Because they're a global body, aren't they?
They are, but they are. You can opt in and out of things, and that's what the US did. They opted out of.
So why can't we opt out?
Well, we should have done it a long time ago.
Because we did leave the EU, didn't we? If I'm not mistaken.
Well, it's UN though.
Right.
Not EU.
Okay. Goodness me.
It's United Nations, isn't it?
I hate that everything's so complicated. Yeah. What's the simplest approach to allowing it in the UK?
Really, a supervised trial is exactly what we need.
Okay, so
so if you look at all of the Australian videos that are going out, they're all saying it's a level 2. It's level 2. Now Australia are a little bit don't have regulation specifically for autonomous vehicles, whereas we do in this country. We've got some already. They didn't put theirs in place, so they're actually not. They don't have enough regulation at the minute to stop it. And Tesla seemed to have sneaked through and gone. They've worked with government and gone, okay, we can do this, and they've obviously demonstrated how good it is, and they've gone, oh, yeah, well, we can do a trial of this. But if you say it's a level 2 system, you must pay attention. A bit like Autopilot does now. It's still a beta. Our Autopilot is still a beta. You still say yes to all the terms and conditions before you use it when you switch it on.
But a quick point. The Robotaxis that are running in Austin, they're level 4, aren't they? Because
they must be. Yeah.
There's no one behind the steering wheel, so it surely must be.
They must be. It must be level 4.
Although it's still human can intervene still, because there's still a human there making sure things. It's awkward, isn't it? Okay, so getting back to the UK, because I'm gonna lose my trail of thought. I'm trying so hard to keep up.
I know.
I love it. I hope everyone's with me still. All right. If Tesla was to just flood the UK then with people like me and other people like you, everyone with their Teslas was suddenly driving around on supervised FSD, there's the data. And then they present that data and go, well, look, these people using it are involved in accidents far less.
Yeah.
That seems to be the commonsensical approach to allowing FSD to be approved in the UK.
The word trained test driver comes up a bit. So they are saying
It's a
that
requirement. That's what they want.
Yes, they're saying that you can't accumulate this data unless you're a trained test driver and you work for the company that are trying to collect the data.
Okay.
In other words, they're saying that because obviously it can do lots of things, and the one of the restrictions is the steering rate. It can't turn the wheel fast enough. It's limited when when EU Autopilot or FSD is trying to go around a corner. It can't turn. The car is quite capable of going around a corner much quicker than it actually tries. It does this curvature assist thing every now and again, and that just seems to stand on the brakes and go really slowly, and it kind of gets around. It does it. Sometimes it works well.
It throttles the car's true capabilities.
So,
doesn't it?
when you've driven an FSD car, haven't you?
Yeah.
How quick does it whip? It really whips that wheel round fast.
Well, I was in a Cybertruck, so only that much.
You're disconnected from the steering.
The wheels were just doing U-turns.
Okay. Yes.
It was nuts. Yeah.
It's an alarming thing when you realise how quickly it can turn the wheel. So the best example I've got right now is I can get in my car, my Hardware 3 car with FSD, and I can summon it using Smart Summon across a car. But if I sit in it with my phone, put my seatbelt on, and then I can Smart Summon myself across a car park. And I don't have to follow it really closely because of the distance regulation.
Right,
the 6 meters of the vehicle thing that it just stops because our phone's too far away. If you sit in it and summon yourself across a car park, you get the visualization. It looks like you're in an FSD car.
That's fun.
But it takes off, and I think the speed's limited to 8 miles an hour.
Yeah.
But even at 8 miles an hour in a car park, it feels quick when it pulls away and off it goes.
You're going to like FSD.
Because I haven't experienced it.
I know, you need to get across it and try it somewhere.
Yeah, dying to.
So we were talking about UNECE's ties to legacy automakers, weren't we?
Yes. Yeah.
How big a problem do you see that being? Is Tesla being held back by legacy auto?
It's so hard. It's all speculation.
Right.
It's really hard to.
That's right. This channel is full of speculation.
Is there a chance that Legacy Auto is doing something as a combined group to prevent something else happening from another manufacturer?
Like Dieselgate, stuff like that.
Maybe like Dieselgate, or covering up your recycling data.
Oh yeah, that's another
with a major trade body in several countries. So trade bodies are doing it. Manufacturers are doing it. They are colluding and yeah.
This is nothing new, is it? So it wouldn't be a total surprise to find out that things are trying to be slowed down. But
this is disruption, isn't it?
Yeah.
Yeah, they will fight the disruption. I mean, you can't prove it, but
no.
But it will. Occasionally it comes to light.
Yeah, at a time usually.
They all got fined for the recycling thing.
Yeah.
They all got fined millions and millions of euros for colluding and withholding information. Along with trade bodies that were supposed to be trusted bodies but they're like clubs, aren't they? They all pay to be members. Do you remember the other Tesla was in UK sales data?
No.
I'm trying not to say the name of the thing.
No, I don't. No.
when Tesla's Model 3 started selling like hotcakes in the UK, it appeared on the UK sales data as other.
Did it?
Yeah, because there were so many that if they didn't put it on, but they're not a member of that club.
Wow.
Tesla are not a member of that club, so they put it on as other, and then they had to take it off because it was obvious who it was.
Yeah. So shady. Still talking about UNECE. Okay, someone left me this comment on the video of you and me at Supercharged. Okay. I thought it was interesting. He said he knows the UNECE are unfit to get Tesla FSD approved quickly, whether supervised or not, because they're rules people who are embedded too much with the competition, and the competition are too far behind. The only way out is to ignore the UNECE and get these test FSD vehicles out on the road through other licensing and have the public see it and demand they have it. As someone in the audience said at the time, this is life-saving tech that should not be held back artificially. Do you agree with that? I mean,
I do. I don't know how you do it. To register a vehicle now I'm going to talk about UK. If you register a vehicle in the UK, you need type approval. Otherwise, it doesn't appear on the list of, I've got one of these cars. You can't select it. To get type approval, you need to comply with UNECE regulations. If you haven't got type approval, you can't register the vehicle, therefore you can't put it on the road. You can do a test vehicle. You could do an IVA, an individual vehicle approval, which is what kit cars used to do. Remember kit cars?
Yeah.
Q plates and things like that. Those are limited production vehicles, and you can do 500 a year like that. So you could actually register a bunch of vehicles under IVA. They go through a minimum amount of testing. They don't have to do crash. They don't have to do any of that stuff. And that gets you around the vehicle regulation, the full vehicle regulation for the UK only. Whether it's worth Tesla doing that, I don't know.
I mean, do you think they've thought of this and all the different possibilities?
I bet they've been through all those hoops, and I bet they've looked at all of it. I mean, again, we're speculating. You can't. I'm sure if they would have found, like they found that, I think the Australian thing is a little bit of a loophole. I think they found a gap in it.
Yeah.
And they're like, okay, we're going to do that.
I wonder if Tesla have a loophole they're fully aware of that they're going to.
Well, I suspect we know they've been driving around on UK roads, but they'll be test vehicles. Yeah. They'll be registered to Tesla, and various authorities will know that those vehicles are being tested in those areas. But fundamentally, they're level 2 vehicles.
Yeah.
So the driver is responsible. If it does something wrong, he needs to grab hold and take over straight away. And I think if you don't drive a Tesla, if you've never tried Autopilot or FSD or EAP, a lot of people don't realise how quick you can take over, how quickly you can grab that thing and you're in control of it instantly.
Yeah.
And the car monitors you for attention, so and a lot of people moan about that as well. Because if you don't pay attention, it will nag you all the time.
Oh, yeah.
So, but if you pay attention, it won't nag you.
Exactly.
It's really clever, isn't it?
I felt that with the Cybertruck. It was just watching me, and every time if I did tilt my head for too long, it would
pings you saying pay attention.
Otherwise, I could just sit there, my hands on my knees for hours, and it would be
so
happy.
you are within the rules. It's a level 2 vehicle. You're the driver. If it crashes, it's your responsibility. And more importantly, it's your insurance that's going to get it.
Yeah. I mean, that's a really a quick point to just mention that was brought up at Supercharge, and people seemed a bit confused by it. Obviously, if the Tesla's in control and you're not in control, it's going to be Tesla's insurance. It's Tesla's doing. Just as if you were to summon a Robotaxi to your door, it would still be the Tesla.
Yeah.
If you're in control of a manual control vehicle, you're in control. It seems easy, doesn't it?
Yeah.
And there will be a distinction in time, I suppose, when if FSD is in control and it has a crash and you're not responsible to take over, then it will still have the insurance with Tesla.
Yes.
It seems logical, doesn't it? So just to put a final finish on that then. So how can Tesla, including through public demand, speed up FSD approval in the UK? Is there anything we can all do? Given its life-saving technology, I mean, that's the point, isn't it? It's like we know it's safer. It's saving people's lives all the time around the world. We see videos of it all the time. We want this to be brought in place to start saving lives. They
already know it's safer. It constantly tops the Euro NCAP testing, especially the active safety features. It's always top of the chart. I feel my car prepping for trained manoeuvres, avoidance manoeuvres. Especially where there's a specific test where you pull out a car pulls out the last minute. There's a stationary car and a car pulls out the last minute to go around it. And if you get that happen in front of you, I feel the car prepping to do something.
Right.
You literally feel it twitch and it kind of eases a bit, and you can literally feel it. It's looking for that situation. It's like, oh, there it is, and it's got it. It gets it way before I get it. It's a little bit frightening at times that it works much quicker than you do, and you look at it and you go, oh my god, that's really. It's on the ball. Yeah. It's got it. It will spot a vehicle decelerating in front of you much quicker than you can. So even with as much restriction now, it's still much better. But how do you translate that into? There must be accident data. There is lots of accident data. So when we do type approval of actual vehicles, we have lots of logging equipment added in. But Teslas log all that stuff anyway. All Teslas log all that stuff. If you have a crash, there's an immense amount of data gets sent to Tesla immediately. All the video feeds get sent. All the logs from the vehicle of what's going on with the accelerator, what's going on with the brakes, what's going on with the steering, what systems are doing what. I think there's like a 10-minute log or something that gets uploaded to Tesla. If you have a crash, especially if you have an airbag deployment, that data automatically gets sent to Tesla.
Yeah, good. And we see time and time again people who have claimed that the Tesla accelerated or something, and then like, no, here's the actual log of it, and you can see the line, can't you? Of like, this is when you press the accelerator pedal, because that's
So crash data recorders is something that has tended to be in more premium vehicles, and there was some regulation pushed to get that into all vehicles.
So there should be.
Not sure where that is.
Why not?
I mean, it's logical. Yeah,
it is. Yeah.
The problem is that a lot of those vehicles just don't have the hardware to do it.
Well, yeah, don't have the capabilities to do it.
Yeah, they don't have the ability to take video from their lane depart camera and record it onto a USB flash drive.
Yeah.
Because that's a separate system. It's not integrated into the rest of the vehicle.
Right.
Because the vehicle architecture is just all wrong, really.
Yeah.
It's not possible.
What is the typical manufacturer's approach to ADAS, Advanced Driver Assistance Systems, and how they want to do it?
They're very much buying in boxes from other people. They decide that they need a system. They don't engineer it themselves. They will integrate. They will do integration engineering of somebody else's. So they will be buying a radar from Continental or somebody who manufactures it, or Bosch. Bosch. They'll be buying a camera from Bosch or Continental. So there are tiers of suppliers that provide equipment into the automotive industry. So they get what everybody else gets. So most of the issues that you see with a radar system that doesn't see something, it will do it on multiple vehicles from different manufacturers, because they're all using Continental radars. So therefore it comes with all the same things. It comes with all the same issues. It's a limited subset of function. You're kind of stuck with what it does when it comes off the shelf. It has a documented interface on how you use it and what it's supposed to do and when it does this and when it does that. And that's what the vehicle manufacturers do. They take that radar, they fix it on the front of their vehicle, and they write the software to make the rest of the vehicle talk to it. So you can turn it on and off from a screen. And all they're doing is sending a command to the radar, say turn on, turn off, if I want to disable this or I want to turn that on. They actually have very little control on how the radar actually functions. So a lot of the radar is an approved piece of equipment that has this pile of documentation that goes with it that says in these situations it does this, that and the other. And the manufacturer then takes that and builds that into their vehicle to make their vehicle accommodate what that radar does. And quite a lot of that is standard documented interface. They all work the same. I could go to any vehicle, plug into its CAN bus and go with a computer and go, what are you doing? And I could see all the radar, and all the messages are all on the same channels. They all look the same. So it's like a universal language of how things work. The problem is that those things don't talk to each other. So if you've got a camera that does lane depart on the front of your vehicle, and you go, oh, it'd be a really great idea if I could record what comes off that camera onto a USB stick for my customer to use for whatever purpose. They don't do that. They're not that camera. The only communication to that camera, it's got power from the vehicle and it's got communication to send it signals. It doesn't have a video feed or a cable or some way of streaming data from it. It doesn't have that functionality, because the camera in that thing is connected to a local processor in that thing, and all it does is that function. It doesn't do anything else. So you could have a vehicle that's got multiple cameras all around it, and they'd all have their little box of tricks that does their thing and their own piece of software. And this has been coming in quite a lot of things recently, that all these manufacturers, I think it was Jim Farley, wasn't it, was saying that we're in a right mess with software, because it all comes from different people.
It's not his only
and it's all doing different. and tying all this stuff together. If you want to change something, you can't change it. It's fixed. It is what it is, and you have to work around what it does.
Basically, the same as the components of the cars themselves. Then, if you've got no control over the parts, you can't just change stuff willy-nilly.
No, and the software is written by hundreds and thousands of different people. If you want to change a piece of software to do something slightly different, you basically can't do it.
Yeah.
I dare say, if you order millions and millions of them every year, if you're VW or somebody and you order 10 million cameras, you may be able to get some changes in the code to do a special feature. And manufacturers like that, because they get all that documentation and all that stuff comes, and it's already been done for some other people, and they can send it all off, and it's an easy tick box to get a vehicle through its approval. But you can't, if you want to do a clever feature, like somebody comes up with an idea, why it would be really great if we could record these cameras while the vehicle's parked somewhere, and if somebody dings it, we've got a video of it and you put it on a memory stick. You just can't do it.
Can't do it.
No. And if you want to do an over-the-air update of something. The camera hasn't got that facility. They're slowly coming with remote update facility. But I bet you there's still 50% of the vehicles, the controllers just can't be updated over the air.
Yeah, wow.
They just can't be updated.
Yeah.
It's not possible. Obviously there's been a push to have over-the-air updates. And some of the newer manufacturers are doing it. BYD have been doing it, I believe. And some of their vehicles have a more Tesla-esque architecture. They've gone for that centralized control, a bit like Rivian have been doing. They've reinvented all their vehicle, haven't they? Their V2 vehicle has got the centralized control method, where you group functions into a single controller. So instead of having hundreds of ECUs, you have 7 or 8. And they become much easier to manage and much easier to deal with because there's less of them.
Yeah.
And you write all the software and you design all your own hardware.
Yeah, well, it makes sense, doesn't it? As soon as Tesla started doing that, my surprise again was, why is no one just copying Tesla? It's like, this seems the logical way to do it.
BYD are.
Rather than hiring,
sure.
Was it Volkswagen who hired that company? Was it Cariad?
Cariad,
yeah. And how many software engineers was there? 1,000 or 2,000 of software engineers to rewrite the entire systems for Volkswagen. But then that's another independent company that wouldn't be. Yeah. It's not integrated with Volkswagen at all.
It doesn't work, and
it didn't work, did it?
No, I don't know whether it worked. I mean. So some systems are easily updatable, like SatNav and the front end graphical interface it can be, because that tends to be where the cellular modem is connected into the screen, and there's usually a gateway to stop, like a cybersecurity thing to stop, because these things as soon as you open up a Wi-Fi port on a vehicle, somebody might try and hack it. Yeah. The BMW i3 has got Wi-Fi on board, but it's switched off. You can't use it because BMW are terrified of they didn't do any cyber security on the Wi-Fi side of things, so they just turned it off and said no, we can't use that. Oh, so it's got Wi-Fi, but you can't use it because they're terrified of it getting hacked. So and this happens all over the place. I've seen it everywhere. It's happening all over.
I now want to ask you about Tesla's being hacked, but for the interest of time, I'm going to try and round it up. Right, okay, so do you see any credible competitor to Tesla's autonomous solution?
Wow, that's a big question.
It is, isn't it? Do you see anything anywhere? I mean, just last week, while you think about it, we saw that company called Tensor that came out of California, not San Jose, I can't remember where it came from. Yeah. But, lovely, shiny advert with the car driving around, and this is supposedly going to be able to buy this car at the end of 2026, and you'll be able to buy it for personal use and tell it to just go home and park or whatever.
There's a UK one called Wave.
Yeah.
Yeah, they've got their running tests. They make automation systems. So they don't make cars. They make a system, a neural net based vision system. They were training with LiDAR initially, and now they've moved on to a full vision system. And they I think they're using Mackeys at the minute. They bolt that into a Mackie, and it appears to work really well.
Okay, so that
we're
could
trying
be
to get the CEO to let me have a little ride in it. But,
cool.
I do know a few people that are.
Well, that would, if you're going to have a bolt-on system, brilliant for all the legacy car companies that haven't bothered trying to solve this. Yeah. But you've still got the issue of that system might work well with what Wave have got, but these other new autonomous car companies that are coming out of nowhere, all of a sudden they've got a few challenges, because not only do they have to solve autonomy, maybe they can with the advent of AI, maybe it becomes easier in the future, especially with vision-only approach, whatever. Mm-hmm. But then you've got the problem of making these cars scalable, profitable, affordable. And if you can't do that, and you're not a car manufacturer, I mean, a quick reminder that it's still only Tesla and Ford from all the American car companies that haven't gone bust yet.
Yes.
Apart from Rivian. Is Rivian there?
Well, Rivian have got a giant pot of money, haven't they?
Well, they're not gone bust yet. Maybe they won't. But the point is...
Are they profitable as companies?
Yeah. But you've got to become a car company. You've got to actually go to the trouble of materials and vertical integration and getting parts and components from around the world to build many, many cars. Prototypes are easy. Production is hard. Exactly. Is the old rule, isn't it? So is there any chance of any new car company coming out of nowhere and solving autonomy and producing millions of cars?
Data is king. If you haven't got the data, you're not going to be able to train your models. You can simulate, you can do lots and lots and lots of things. But ultimately, real-world data is the thing that is the difference between...
Which is what Tesla has in abundance, because it's got millions of cars out on the road.
If only you had a few million cars running around with cameras all over them and hardware to collect data and then upload it when it gets back on the Wi-Fi.
I suppose it's not totally out of the question, though, is it, to suggest that in the future there could be breakthroughs in AI as things keep happening that comes from simulated data.
Yeah.
I mean, there's a possibility in the
simulations future. Are really, but you and Tesla use simulation a lot. You know, they we know they use it a lot. They built a one of the earliest things that they did was build a full simulator, because they realised that you're chasing the nines is that, you know, you're 99.999 and you need to get better, but you can't get better because those situations don't occur. I'm delighted that we've heard nothing negative about Robotaxi.
Yeah, me too.
Months and
I love
months
the fact
have
that
gone by.
It's almost boring.
It would have exploded if there'd been an issue with it. And there's that lovely website you can look at. You should have a link to that.
What's that?
The Austin autonomous vehicle website, where you can look at the crash data.
Oh, right.
Because every crash that happens has to be reported to the local authority that's in charge of autonomous vehicle regulation. There are lots of crashes on there, but they're not Tesla.
No.
There's one safety incident so far from right back at the start.
Right.
And that's it.
Yeah.
I think the others have got 180 safety incidents.
Right.
And if you look at those safety incidents, there are a lot of them are minor. Yeah. In fact, a lot of them are humans running into the back of Waymos. Loads of them are humans running into the back of Waymos. Probably because with all its sensors, it spotted something, stopped, or it was a bit cautious, and the human got impatient. And then
if the car in front of you stops for no reason, I mean, there's likelihood that...
So there's an awful lot, because they have the report sheet. It's really cool. They have the report sheet. It's like when you get a hire car and you have that car with those boxes on it, and you put the crosses on where the damage is. Yeah. And they've all got rear end, rear end, rear end. Yeah.
There's an awful lot of Waymos right now. I'm seeing the videos of them driving into fire engines, driving up the wrong way street, stopped on roundabouts.
With reversing in a traffic light intersection with 2 lanes of traffic batting past it.
Yeah. And then meanwhile, Tesla Robotaxis so far, it seems to be an extremely boring rollout, which is perfect.
Find some wood to touch.
I know, I'm not superstitious, but I'll touch some wood. It's not even proper wood. But I think so, it might be.
Touch formica.
The varnish. Yeah. How does Tesla handle GDPR and privacy concerns for FSD data in the UK? So that's General Data Protection Regulation.
Yes.
So
you already do it.
Right.
There's terms and conditions, and you accept how much data you do or don't want to send to Tesla.
Okay, so no big deal there.
So yeah, you could buy a Tesla and you could say, no, I don't want you to look at my cameras. I don't want to look at. It's already in the vehicles now. You do it because you're driving a vehicle around with 8 cameras on it, recording everything all the time. Yeah. The only reason that they could have for accessing camera data is accidents. If you have an accident with a fatality in it, they will legally come after that data, and Tesla will have that. And will need to produce that data because they have it.
Right. So if you choose to say no to the cameras, then the internal camera, you just won't be able to use FSD in the future, will you? So that's a choice you have to make. Is there anything to be said about the cameras, obviously recording pedestrians and people's privacy issues there?
In this country, no, because you're in a public space. You can take a picture of anybody anywhere.
Oh, well, I suppose, Okay, good. We're getting to the last few questions, which is great.
Is it coffee time?
Oh, flipping it. It's coffee time, lunchtime. It's everything time. What's the status of FSD testing in the UK, and how will it speed up approval?
It's very secretive. It is happening. We know it's happening. Yeah, I think if you look hard enough, you'll see it. You can see it happening, and we know that Tesla have put videos out from multiple countries around the world of them with vehicles running around on FSD in cities and all over the place. Yeah. We had the Magic Roundabout video, which was amazing. Yeah.
Well, it's basically, if you don't know it, it's one roundabout with 5 roundabouts around it. Yeah. And everyone just gets there and goes, what the...
What am I supposed to do?
Who did this? But apparently lots of locals actually say it's fine. Yeah. Once you're used to it, it works.
I mean, the theory, the theory works, doesn't it?
Yeah.
It's,
but to see a Tesla driving around there, which I'm
it was confident
right now,
yeah,
confident, did it 3 or 4 times, didn't it?
Yeah, they did different junctions, different lanes. I think there was one where it could have gone a quicker route and it went it went further in than it needed to, and it could have just turned left. But it decided all right. I can't. But anyway, it was impressive because the thing that because that was the challenge 2 or 3 years ago. Oh, I bet it can't do Magic Roundabout. Yeah. I bet it can't do country lanes down in Cornwall.
Yeah, yeah.
Narrow roads, well, there's no road markings down here. Well, it doesn't need road markings.
No, because again, it's because it's trained on
yeah.
humans that have already driven these routes before millions of times, so it knows how to interact with other vehicles. So if you do have a one-way street in Cornwall and you both end up together, I mean, the cars would have to communicate, and one of them would have to move back somewhere, one of them would move back the other way.
There has been talk of having cars that, the answer to this is to have cars that communicate with each other. Like direct communication with each other.
What do you think Teslas will do in the future?
I don't think they need it.
Would they need?
I don't think the neural network doesn't need it.
Imagine my scenario of two cars getting right to, they just see each other and go, well, one of them's closest to a turning point behind them.
Yeah.
And one of them would have to reverse, but they can't both reverse at the same time. They're just sitting there.
I mean, it's one of the trickiest things seems to be this. I think they call it persistence, where it's basically the car's memory of what's gone behind.
Okay.
What's happened behind, and for things like when you drive down a country lane, you remember where that last lay-by was, a quarter of a mile back, that you're going to have to reverse all the way down the lane if somebody comes the other way.
Yes.
So if that persistence can be long enough, then the vehicle will know that there's a place where these two things can get past.
Yeah. But there's no point in both of them going back to that spot. They would need to go, well, we'll give you right of way. How will they communicate?
Have you seen the Waymos in the car park?
Yes, I have. I did a video about it.
They're all like
I could barely get through.
And they just go completely stuck.
They're just all beeping at each other.
Yeah, I don't know what's going on. They're just completely stuck.
Someone was doing a 24-hour live stream of the of the beeps because it just kept them up all night. It's like, I haven't slept for days.
Oh no,
it was hilarious.
So that's the thing with neural nets. They are because of the way they're trained. They are very natural. They behave like brains. I was over the moon. I asked Josh about it, didn't I, at our talk at Supercharged. When it goes through a corner, what's the line it takes? Does it feel good through the line? He said it's superb. It really does take lines, and it feels confident, and it moves to the right place of the road, and then it takes the line, and it can carry speed through corners. Because what we've got currently here is an absolute nightmare on, I mean, it's supposed to be for highways only, is it? For motorways. And looking at some of the latest stuff, and I'm loving the videos from our from Australia right now, because they are
And New Zealand.
And New Zealand, yes, and it's fantastic seeing that stuff happening. But just watching those full-length videos at proper speed, where they're not sped up or slowed down or anything.
Yes.
Watching the vehicle moving a little bit in the lane to give a little bit more room, and doing what humans would do. It seems a very human driving experience, and I'm really happy to see that.
Yeah, it does. Yeah. So it's hard to believe there's 7 countries now.
It's not a robot. We call it a robot, but it's not.
It's a human
behaving in a robotic fashion, is it?
Yeah, it's strange, isn't it? Yeah.
It's incredible to think of.
I just can't wait for it. Well, what an exciting time to happen to find ourselves alive right now.
Yeah.
In the time that this is all happening. And yes, it's very exciting. I won't get into all the reasons why it's exciting, because this video will go on forever. And listen, if you haven't had enough of me and Dave, we're going to continue this conversation over on Patreon. Okay, so if your brains are capable and you're following it, I've been given some great questions from my Patreon audience that I can't wait to ask you and delve into even more weeds. So thanks so much for being here, Dave. Really appreciate it. It's
very welcome. Very well. Anytime, Will.
Cool. Thank you. I'm Will. This is the Tesla Jigsaw. Thank you, patrons. Thanks for watching. Bye for now.